Welcome to lecture 58. This lecture is basically on the application part. So, whatever you have learned the tools and the techniques to collect the geomatics data, now we have to apply it for a certain application. So, in this lecture we will talk about that how site suitability analysis can be carried out when we have the different data sets in the GIS database. So, we know that the GIS applications are growing, whether we are talking of the real time application of the GIS, or whether we are talking of the visualization of the data, or whether we are talking of the smart devices or creating a web GIS services. So, everywhere the GIS has its application. Now, this is helping us to become smarter. The meaning of that is that it provides us the flexibility to carry out the analysis as per our requirement. It actually gives us lot of flexibility to integrate the data according to a specific rule, according to the specific criteria. So, you can actually establish the relationship, you can see the pattern among the data, you can see the hidden information from the data, and you can carry out the prediction, you can carry out the modeling. So, there are different ways actually these GIS are helping us, and this is making us more smarter to take the decisions. When we are carrying out the mapping part, we can carry out the smart mapping from the data, or we can carry out the data visualization or 3D cartographic data. So, there are a very large number of applications are there of this data. So, how this entire data sets could be used when we are doing some kind of a project planning on the earth surface, we require first of all the suitability of the land. So, if we want to find out the suitability of the land for a dam site, or if we want to find out the suitability of land for growing the crops. So, that land suitability analysis has become very important, and there are large number of applications of the GIS where looking at the whole area with a similar approach, what we do is we prioritize the area, we find out which is the most suitable area, which is the least suitable area, and focus more in the most suitable area, try to collect more and more parameters in detail and try to study that and then find out what is feasible and what is not feasible. So, this example shows here that in a general diagram of the site suitability modeling, and here we have the lake, a map of the lake, map of the road and map of the hydrology status. And then we are creating buffer zones and we are recoding this area into the wetlands. So, the first two maps are the buffer zones which are created around the lake, the second one is the road buffer map, and the third one is the wetland map. Now, we are combining the first map, the first two maps which are the buffer maps, and we are getting the combined buffer maps, and then we are creating this buffer maps with the wetland maps, and we can find out which are the suitable areas to develop as the wetland area which have good connectivity, which are closer to the road, they are connected to the road, there are lakes also available in that particular area. So, we have those grey areas are the suitable areas and the other areas are not suitable. So, that means we can narrow down our approach, we can narrow down the focus of planning in those areas. This is another example where we can find out the site suitability analysis. Suppose we want to carry out some construction activity in a particular area. So, we want a road map because we have to see the accessibility, the site should be accessible from the road. We have a land use map which you can create from the satellite data. Then you have the slope map, digital elevation model will give you the slope of the area. So, you have three kind of maps in this example, and the road map will give you the accessibility, and you create kind of a buffer, and then you know that the space locations which is away from the road has a poor ranking, and which are closer to the road had a high ranking, good ranking. Then the land use and the slope, let us say we create a land value map. So, flatter area will have more land values and the hilly areas will have the lesser values of the land in terms of the cost of the land. So, we use some kinds of weights here. So, this is the ranking and these are the weights. Accessibility is given 65% weightage, land value is given 35% weightage, and when you club them together you can get some kind of a site suitability map. So, the weights and the rankings are to be defined by the user on the basis of some experience, on the basis of the previous literature review, and if you use the ranking and the weights method, then one can derive the site suitability map. Now, it is very important that this site suitability map which you are deriving through this mathematical modeling has to be cross checked with the reference data verified in the field before it is used for further analysis. Now, this example is showing lots of maps on the left side where we have land cover map, soil type map, slope map, distance from the streams, river network, and distance from the roads. So, buffer map which is created. Now, from these different maps you create some kind of a suitability layer. So, land cover suitability layer is created, soil suitability layer is created, then slope suitability was seen, stream suitability, road suitability, and this was done actually in order to identify here the different sites. So, now if you are clubbing them together you can get the output something like this, and this is indicating that how you can get the most suitable, highly suitable to the less suitable areas. So, this example shows that how you can club them together, you can give a certain kind of a weightage, and then you can arrive at the high suitability area to the low suitability area. So, you can do this kind of a criteria in GIS. Now, suppose we want to locate, we want to find out what is the optimum site for the warehouses to supply some kind of a product outlets at the national level. So, we want to cover the entire nation, and we want which are the optimum site locations, so that we can actually have outlets at those particular points. And also you have a condition that you do not want to wish your warehouse to be more than 1000 kilometer from any outlet. So, you do not want that that warehouses to be more than, they should be within 1000 kilometer distance only when you are selecting more than one. So, this example shows that the population data, who are the users, who are the customers when you are want to start a warehouse. So, this population data, population density data is indicating, different colors are indicating the different population density. So, on the basis of the population density, which is one of the criteria to decide which are the optimum locations for that, and this is the intersected road network. So, road network is superimposed on the population data in order to see that which are the highly populated area, number 1, number 2 is that which are those areas highly populated and connected by the road network, so that there is accessibility, people can go to the warehouse. Now, on the basis of that kind of a analysis, one can carry out some kind of a tentative analysis of the locations which are the possible locations. So, this is called the candidate locations, which are the possible locations, and you can see those bigger spots are indicating that these are those possible locations where the population is also high and the area is also connected by the road network. Now, you have to narrow down, suppose you get 20 possible locations, you cannot actually start your warehouse at those 20 locations. So, again it is an optimization problem, you have to optimize the things. So, when you carry out the optimization, this is one example, suppose you have a one warehouse here in the Illinois, and as the distance wise also you can see that with this one single facility you can cover 46% of the total area of the nation. So, you are considering 46% population of the total area, total nation's populations. Now, suppose you want Nebraska is the another point. Suppose you want another, you want to open the another warehouse at this particular locations, which you get from the GIS based analysis, then the area covered will be 59% population area would be covered. So, 59% of the population would be covered, but since our aim is nationwide, so we want to cover 100% population by the warehouses. So, we want probably some more locations. So, let us narrow down the further our approach and see that if we have 6 sites. So, all those red dots are indicating the 6 possible locations where warehouse could be open, and probably the 99% of the population would be covered with the help of these 6. But if you further increase, see the optimal here is now 9 sites. So, from 6 we have now 3 more warehouses where we find that you are covering almost 100% of the population. So, that means now you got the optimal locations of those particular sites where you can start your warehouse, and then you can cover the entire nation also. Distance wise analysis you can carry out, that how much the people have to travel if we consider the connectivity to those warehouses. So, one can see that how those 9 facilities have been connected with the distance also. So, that analysis one can carry out very easily. This is another example of the industry sites in Banda. So, if you have to identify which are the best industrial sites in the area where we can set up the industry, or we can declare that as an industrial area. So, this is the satellite image of the area, and along with the satellite image you can you can generate land use land cover map from the satellite data, but what you require is you require the connectivity. So, you require maybe the train connectivity, you require the road connectivity. So, rail accessibility, road accessibility is required. Then you have to see that the site should be away from the river, because it should not lie within the floodplain zone of the river. Then it should have a proximity to the urban area, the customer, the user of that. So, there are several parameters which one can collect the data and create the GIS database using these parameters, and then give certain kind of a ranking to those parameters, weightage to those parameters. So, depending upon that you create some kind of a score system, and once you have a minimum range of the score and the maximum range of the score, when you are adding overlaying these parameters, then you can categorize them. So, you can see the relationship here. The suitable score has been derived using land use, railway accessibility, road accessibility, distance from the river, proximity to urban area, and then when you combine together you carry out further classification of the suitable area into suitable, moderately suitable and unsuitable area. So, this is the categorization on the basis of the ranking weighted score which you get, and you can find out which are the best areas, which are the moderately suitable area and which are not suitable at all. So, here red one are those areas which are suitable, the blue one are moderately suitable, and the yellow one are not suitable at all. So, one can actually find out that which are the best areas and then carry out the detailed analysis of that area by collecting some more field based data, socio-economic data and so on. One example of the transmission line. So, when we are carrying out some kind of a alignment study, whether it is a transmission line or it is a new railway line or pipeline or it is a new road, then GIS is playing very important role in that case of a study. So, the example is taken from transmission line management, where a lot of power engineers now are using the GIS for laying out a new transmission line or identification of the faults. So, they can find out the locations, exact locations where the fault has really occurred and made the system down, or repair and the maintenance activity also, because for the repair and maintenance activity also you require a region, you require the location of the site. So, this is a routing model flow chart for alignment of a new transmission line. So, when we look at this model flow chart, we have certain input parameters, and those input parameters are houses, location of the houses in the area, then the road, then which are the sensitive area like the forest areas could be the sensitive area, then the elevation zones. So, we have actually the input data, and from the input data the second layer here is the derived maps. So, you can derive several maps from the input data like housing density map, the number of houses in per unit area, proximity to roads. So, you can create a buffer map of the area, proximity to sensitive area because you have to plan it away from those sensitive area, then visual exposure to the houses, the visibility analysis, intervisibility analysis, which I have shown in the earlier lecture. So, you carry out that and then you create some kind of a criteria. You are avoiding the areas of high density, the alignment should be far from the roads, it should not be near the sensitive area, and high visual exposure. So, you have to take care of these, assign the weights according to that, club them together and find out which are the best areas which you can determine. So, you are creating from the input raw data, you are creating these several maps. You are creating the high housing density maps which you are creating. Then you are creating road buffer map, then you are creating a buffer map of the sensitive areas and the how much is the area which is visible to you. So, different layers have been created. The top is indicating the 3D model of the area where you are planning. So, you have a location of the proposed substation and you have the existing power line in the 3D environment. So, when you are routing and deriving what is the optimal path, you have to see what is the most preferred scenario and what is the least preferred scenario. So, you have to identify in different steps that this is the most preferred and this is the least preferred. These are the areas which could be avoided, these are the areas where obligatory point from where the alignment should pass. So, once we determine that kind of a criteria, then step by steps we can actually apply those criteria, give the ranking of those parameters. So, here 1 to 9 ranking is given to the different parameters, and these maps have been, as you can see from the different colors, that map has been created which we call the preference maps. So, this is the preferred class. So, the preferred class is given the higher ranking and the other classes are given the lower ranking, and then they are combined together. Now, this is a preference map which we are creating. So, one can see in 3D environment also the low cost areas are those areas which are the favored area, right. Then there are most preferred areas and there are least preferred areas. So, this color diagram is indicating the best to the worst. So, dark green is the best and the red color is indicating the worst area. So, the software will actually pick pixel by pixel and will see which pixel is meeting the criteria, and it is generating a route. So, when you change the weight, little bit weight from one parameter to another parameter, it will generate another route. So, it is always better when we are doing the alignment kind of a problem, it is always better to generate several alignment, several routes, so that we can find out which is the best alignment. So, one can see here also that there are 3 alignments which have been identified by the software when we are doing that pixel by pixel analysis and find out which is the best location, which is the suitable location. Now, When we have the three alignments, then we have to carry out the further analysis that which one is the least cost, the low cost or least cost route out of the three routes. So, that least cost analysis also can be carried out on the basis of the certain parameters, whether it is crossing a particular area or it is going away from that particular area. So, accumulated preference map is created. So, when you are creating the accumulated preference maps, then you can identify that at the end that which is the most preferred route. So, all the blue dots, the pixels which are joined together, they are making a route, and this is the preferred route because it is not only meeting all the scientific criteria, but it is the least cost route also when we are carrying out the alignment study. So, now when you are carrying out this kind of a alignment study, you can put it on the 3D model, and then you can see that how this route is passing through the different points as far as the slope is concerned, as far as the housing area is concerned, and you can finalize the route. This example shows that how to find out the suitable locations of the mobile tower, and particularly the BSNL mobile towers. So, this study is undertaken in Pithoragarh District. You can see this district boundary, and you can see there are existing towers, BSNL towers, but since it is a hilly area, so there are certain areas where you will find the density is quite low, or there is no tower at all. Particularly if you focus in the upper part of the Pithoragarh district, which is the highly hilly region, you find that the density is quite low as compared to the lower part where the towers are quite dense together to provide a good mobile network. Now, if you take some kind of a scientific criteria, what is the criteria to establish a tower, how much area it should cover. So, you can find out some of the new locations of those towers. So, some new locations can be identified with the help of the defined scientific criteria, carrying out the spatial analysis in GIS, providing the weights and the ranks to those different parameters. Now, this is another study which I wanted to show you about the rainwater harvesting in the Missouri region in Uttarakhand, because this rainwater harvesting is also more or less compulsory, looking at the situation of the water availability in the country. So, we can identify which are the best locations for rainwater harvesting, or which are the best government buildings where this rainwater harvesting could be started. So, this GIS is playing very important role, as you can see here, that this is the different zones in the Missouri. So, there are 5 different zones: Library zone, Gun Hill zone, Vincent Hill zones, Lal Tibba zones, and the Mount Rose zone. So, different colors are indicating the different zones and the area covered. Now, I will quickly go through the different maps which I will show you here. The population density map. So, the different zones have the different density of the populations. Then the slope map, altitude map. So, different regions have the different altitude. This is the hilly region, quite hilly region. Then a drainage network map. So, all the major and the minor drainages maps are shown here. Then building maps. So, in each and every zone, now you try to carry out the footprint mapping of the building, which you can do very easily nowadays with the high resolution satellite image. So, once you have the footprint of the building, you can also identify how much is the rooftop area of each and every building. This is the open area map, how much is the open area in each of the zone, that also you can show, and then what is the water demand in each of the zone. So, in terms of the quantity MLD, you determine the water demand zone, because some of the areas are actually all the time having lot of crowds from the tourists also. Then water supply, how much is the water supply available, how much is the water demand because of the tourism in those areas, as well as the population, local population. Then the water shortage map, which are the locations where the water is short. So, you can see the yellow one is showing the highest shortage, then the low shortage is there in the green region. So, these are those regions where probably the rainwater harvesting is very important. So, when you identify the areas with the shortage of the water, then rainwater harvesting could be proposed in those areas. So, priority can be made. Now, we see that when we are doing the dam site selection also, this remote sensing and GIS technique is playing very important role, because you have to find out the flatter areas, or the river is width is narrow, and also there is a sufficient space to create a reservoir behind the dam site. So, there are certain criteria, there are certain parameters. So, maybe you like to have a slope, geology, soil type, catchment, land cover area, proximity to river, proximity to roads. So, all these different layers can be created from the different data sets which you have learned so far, and then you can club these data sets, create on the basis of the criteria the another data set, and find out which are the best locations. So, this is the satellite data, multi-rate satellite data will give you the change analysis also, that how the reservoir area or the water ponds are changing in the region. So, once you collect the data from the various sources, satellite, field, soil map, digital elevation model, then you can club this data and determine which is the best location. So, this is from DEM defining the catchment. So, that pink area is the catchment area which is defined by the digital elevation model. These are the different layers which have been created in the GIS: slope layer, land cover, land use map, geological map, and river proximity maps. So, these are the different layers. Along with these soil maps, different soil category, the catchment area, road proximity. So, all these maps are now given a certain ranking. As you can see, those 1 to 5 rankings are given, they are given certain weights, and on the basis of that now you create a suitability map. So, it says that highly suitable areas are the blue areas, and you can see one big blue chunk of the area and another one is here. So, there are 2 areas covered with large number of blue pixels. So, these are those suitable areas which could be considered for the construction of the dam. So, this is the way you can use this analysis, site suitability analysis maps for various applications. Thank you very much.